So now look at the interesting situation. You have the display, which is large. You have the hose coming from the top. You have a vertical organization. Earlier there were boxes, right? Now you got a vertical sleek look. So the organization and form is very, very critical. And you had to come up with a new design. Why do you think there's, you're able to dispense faster fuel from this?
More pressure with the hose from the up.
More pressure from the up. That's a good point. What else? But I have more head, no? If I have more head, will I get more pressure?
But there's a motor pumping it all the way to the top.
Anyway, the motor is pumping. Very good. The motor is anyway pumping, so I took it up. But then why should the delivery rate increase? For example, the Z-Line was giving us 45 liters a minute. So you can service 500 cars a day. Whereas this pump was giving us 55 liters per minute, nearly 20% more. You could service 600 cars a day. So 100 cars more is huge business. And what are the other advantages having the hose from the top? Tell me.
More range.
Excellent again. You get more range. That is, you can go much farther and fill petrol in the trucks and cars. What else? What else is the advantages of having a hose from the top?
You don't have to lift the pipe.
Damn good. The pipe is so heavy. There's 2 liters of petrol in that pipe. So 2 to 3 kilos is the petrol inside, and the hose is made out of rubber. And hoses are very heavy. Like if you carry them, they'll be some 8-9 kilos. So just imagine the whole day that guy is lifting this hose 500 times to fill petrol in cars and dragging it along is quite a job. So now what you have? You have a hose which is hanging from the top. So the load is not coming onto the person's hand. The fellow on the top is taking all the load. So range is high. Excellent lightweight. The operator, who's my secondary user, is very, very happy. He's not tired at the end of the day. What else?
Doesn't get tangled.
Doesn't get tangled under the tire. So generally cars go on top of the hoses and the hoses get damaged and you have to replace the hose every year. Here, there's no chance of any damage. You all understand what is a chassis, right? Frame. So this whole pump was built on a chassis. Then it had this, convenience for mass production. I'll come down to that a little later again. It had a large display fascia. You saw that large glass and large fascia was very critical because at that time we had this large TVs coming into the market. So people were very tuned to seeing large displays, and it satisfies the international norms for safety. Midco very early told me that we want to export this pump all over the world. So the standards have to be met, and when standards have to be met, explosive standards are very stringent. You need to have something called an air gap between the electronics and the hydraulics. So can you see that air gap in the middle? Why do you need an air gap between hydraulics and electronics? Any guess?
Sparking can produce.
Any sparking in the electronics can, produce fire and explosion, because that environment in the bottom is rich with hydrocarbon, rich with evaporated petrol or whatever. So you need to have a barrier between the two, and that is an important norm. We used computer aided design a lot, and we had very, very high accuracies and very, very high modular design. So how computers helped us was, once you make this structure we could fit a single pump and double pump also. What's the advantage of this? Again, less number of parts. And Midco is not a company like L&T which had all its manufacturing in-house. So what they were doing? They were getting components from the vendors. So when you were getting components from vendors, it makes sense to have modular construction where you can have the same components again and again. Look at this whole array of first prototypes. In fact, as soon as Manoj joined the company, while he was in IIT, he produced this one first pump. After coming into Midco, he produced all these pumps which are all different. It's a mechanical pump. So can you imagine the advantage we have of putting a mechanical register into the same body? Why do people use mechanical pumps in rural areas? Tell me.
Electricity.
Severe problem of electricity, and they crank. You know this? Yeah. They crank and they dispense. At that time, power was a serious problem. So just look at the beauty of this design. Manoj could actually fit a mechanical register in this, and and have this all the advantages of the new design and the advantages of modular construction. Very, very cost effective. And then you had the dual pump, both sides pump, and the single side pump. So we had all the options over here. So let me quickly show you now the results of the research. So this was research, right? So while Manoj was in the company, I was finishing my research and I think, how does this success happen? So this was the model we developed, which I showed you earlier also, the core team, the enterprise-wide team and the network team. Very important. Any project you do, even if you're doing a BTP for your project, if you follow the teaming, you'll get phenomenal success, and this happened regularly every time. And then what happened with this success, you need to also divide your stages into multiple stages. First you have ideation, multiple concept generation, prototyping, mock-ups. So all those stages are also important. So while you have this collaboration across teams, you also have steps in going through. And now look at these team members. The core team is made up of Manoj Dubey and 4 other engineers, CAD engineers, prototype engineers in the company. A very small team. But what was the bigger team was the enterprise-wide type cross-functional team. This was very, very big. Look at the beauty of product planning in Midco pumps. What was there? From mechanical pump to single pump to double pump, and I'll show you one more, to premix pump. I'll tell you what premix is a little later. So we had excellent product planning. The companies survive on investment, right? How much investment you do on your prototyping and on your different components on your manufacturing. So investments are low and you have large range of products. That is very critical. Now there's a chassis, right? So use less sheet metal, and the chassis was cheaper than using sheet metal to mount, because chassis is very strong. And look at these pipelines. The same pipe I'm using 2 times. And this pipe is done using special aluminum alloys in special CNC machines. And now coming to my hose on the top, L&T was using cast iron conduits. What happens inside cast iron? The inside surface is rough. Aluminum pipe, inside is smooth. When the surfaces are smooth, you have much better flow. So our hose, which is giving 55 liters per minute from the top, actually is being aided by the smooth aluminum pipes inside also. Look at the air separator. This is the air separator. This is the meter. And these are the copper pipes for the air separator. And this is the motor. And how all this is possible? Because of CAD. We could develop the modular system so well, and CAD was used extensively.